So last time we did a few exercises on strings. We understood, we learned that strings are sequences of characters, right? This property of a sequence of a collection of data being a sequence we're gonna come back to it over and over, right? It's the easiest way to assemble a bunch of data together, and we need to aggregate data if we are to process data, which this course is supposed to sort of look towards. We have to aggregate data, right, in order to process it, and the easiest way to aggregate data is as a sequence, right? So we have to get used to creating sequences of all sorts. So what I'm going to try today is two things. Introduce a new type of collection called a tuple, right? And this comes in as an immutable sequence, right? A sequence that cannot be changed. And this is very similar to string. One thing that I should have emphasized last time, and I sort of forgot, is that strings are immutable. So if I say that S is a string ABC, right, I can select S1 and get out of this string its second character, but I can't say S1 is assigned, let's say, Z, right? That I cannot do, right? In this sense, it's immutable. We're going to see data structures and collections that are mutable. They can be changed. So just to give you a very simple example, I can have a list, right, which is something that we create with square brackets, and I'm going to have the same kind of selection. S index 1 will give me the second element, but here I can say S1 equals 10, let's say, right? And if I check S, and you see that there's no error, and if I check S1 again, I'm going to see that it's changed. But what we want to introduce today is a tuple, which is created by using round brackets. So we're going to say 1, 2, 3. This is very much similar to the tuple that you know from mathematics, right? And I can access the second element with T1, and I cannot assign T1 to anything else. All right, so attempting the assignment is results in error. All right, does that hamper us, the fact that we can't change it? No, because we can always create new elements with new values, right? So if I want to create a new tuple with its second element changed, right? What would I do then? Well, I would say I created T, so I would say T0, up to element 1, right? Plus, top, I think it's top of 10 plus T from 2 onwards. Sorry, up to element 1 exclusive, right? From 2 onwards, right? And top tuple give me a second. Oh, it was there, so it says tuple constructor. Oh, I see. It has to be some other sequence. So we're going to create a tuple out of a list containing 10. Actually, one thing we can do, let's not use tuple and let's not introduce lists. One thing we can do in order to make it a tuple of one element is to put a comma here. All right? So what are we doing, right? We're taking, we want to replace an element, right, in the second element in the tuple, right? So what we're going to do, we're going to take all the elements up to that element, we're going to replace it by 10, and we're going to take all the elements after it. And this should work fine, right? So you see that we have a result that is another tuple where we have replaced the second element by 10. But notice now that the old t is the same, hasn't changed, right? We can always do this. We can always create new values and leave the old ones unchanged, right? And this is what we have done with strings. So everything we learn about strings, and that's the beauty of Python, everything we learn about strings still works for tuples, right? We learn how to select elements. We learn how to compute the length, right? I can still say length t, right? And I'm going to get a 3 here. Yes?
Sir, I'm a bit confused about, is that window from the text editor, or are you typing it in the terminal?
I'm typing it in the terminal because I just want to show you very quickly a few, the way a few things are working, right? So we are doing selection, we are doing length, and guess what? Reversed and sorted still work pretty much in the same way as before. So I'm not sure if I have it here. All right. So I have this expression using sorted. I'm going to delete the argument, and what I'm going to put inside is a tuple, right, of numbers that are completely arbitrary. Well, I'm doing my best to. All right, notice the 2 levels of brackets, right? The first level of bracket, what you see here, is the call from the function, the invocation, and this is for the tuple, right? And we have to close both brackets. And if we do this, and actually I'm not going to say join, I'm going to say tuple here. Okay. And as I come here, I will have to add another bracket. All right, so you see the tuple of sorted numbers now, right? It has the same length. It's a completely different tuple from the one before, right? So one interesting thing we can do is set this value to a tuple t1, which should be assigned, all right? And then perform this operation on the tuple t1. Put this value in t2. Sorry, t1 here. All right, and then look at t2. And we can look at T1 and notice that T1 is unchanged, right? So we are never modifying anything. We are only creating new objects. All right. So the interesting thing that we're going to have now is that our codes, our piece of code that we wrote last time, are going to still work with tuples. All right? And I want you to remember this, right? So the Python is designed in such a way that it works uniformly with all sequences, and therefore code that processes a sequence generically will work with strings, tuples, and later we're going to see lists and possibly sets, and so on, right? So I'm going to create now a new file, and I'm going to call this tuples. I should create here a new folder to Monday, and save. So I'm going to take not all the code, but just the two functions, or the three functions that we have defined. Actually, it's 4 functions. All right, I'm going to remove the qualifier string. And I'm going to say max sequence, but notice that I'm not changing anything else. All right, we can save them, and let us write some tests. And okay, so let's start with the max sequence, right? So print so the first test will be print what did we used to do previously? Let's take a look. All right, we would have a value, test1 will be a tuple, and we can have tuples of numbers, or we can have tuples of strings, or we can have tuples of tuples. All right, so let's start with numbers. 2, 0, 7, 9, and we're missing a comma here. So we're checking whether max equals max, right? So and we're going to say here max sequence test1 equals max of test1, and remember that we have a test function already, right? So we can run this. I'm going to exit this, exit, and move from here to week 2. Oh, come on. All right, so I'm going to do Python here. Sorry, we're going to do tuples here. And the result of test 1 is true, right? I'm going to leave it to you to write more tests. Right, so it's always good to separate and essentially document your programs, right? So one way to document the program is using these long strings placed in between triple quotes, right? So we can say here a function that finds the maximum of a sequence. Right, we could do a similar thing here. Right, and we should write a bunch of tests. Okay, so I'm going to leave that to you. So print homework. And next, we're going to go and check the sorting. Right? So we're going to say print tests sort. And so let's take, and I'm going to take the same variable, right? Because this is just something that, but I'm going to call it test2. Maybe you want to change it later. And we're going to say print result of test2. And we would have sort of test2 equal, and we're going to use the expression that we used here. Right, so tuple sorted t2. Okay, so again, we can run this. And boom, unsupported operand type for int and string. Why is that? All right, so now it's interesting. So you see, in case of the length being 0, the input sequence being 0, right? We have to return an object of length of length 0, right? And we chose to return the empty string. So that's not good because the empty string and the empty tuple don't mix together, right? So what should we have done here?
Empty tuple.
Well, so then how do I make it work before the empty string? I still want it to work for either case, right?
Can I just return none?
No. None is different from the empty string, which is also different from the empty sequence. But do I have in the function the object that I need? How about if I return S? Right? So if the input is a string, at the point, if S is a string, then because of this, S is necessarily the empty string. If S is a sequence, because of the same condition, S is necessarily the empty sequence. Right? Whatever collection I'm going to have there, S is going to be the empty of that collection, of that type of collection. Right? Is that clear? Okay. And we still have a problem. Between int and tuple. So this is min CQ, right? Which we have defined above. All right, so there's another problem here. Anyone can spot it? So there's a little trouble with S, with indexing with strings. All right, and I'm going to go back here and right, let's say that I have a string S which has the value A, B, C, and I say S index 1. What's the type of S1? It's a string, right? It's not a character, it's a string. However, if I take a tuple, T1 is an integer. It's not a tuple created as an integer, right? So there's a little problem there because Python doesn't want to complicate things. It doesn't look as S1 as a character, but rather as a string. Yes? No? Right? Meaning that, you see, I can do T plus XYZ and, sorry, not T1, S1. I can do S1 plus XYZ, but I cannot do T1 plus 10, 20, 30, right? I can only do tuple. Sorry, let's not use tuple. So this is a tuple of one element, right? I can only do this. Okay? So now, we would actually need to, if we want our program to still work for both strings and other sequences, we will need to check whether our type is a string. How do we check if the type is a string? All right, so I can do something like this. And find out. All right, So if I check that type ABC equals type of the empty string, I'm going to have true, right? If I check that's type of an integer, I'm going to get false, right? So one thing we can do here is we're going to create the expression here. Right? And no, actually there's a simpler solution. Can someone figure it out? All right, let's go back to here, okay? So you see, I can say S1 plus XYZ. I can also say S1, 1. Sorry, x1, 2 plus xyz, right? Same result. Now for t, I can do the same. t1, 2, right? So now it works. So can you kind of figure out what the solution is going to be? All right, so we're going to work in 2 steps. So we're going to take this min_seq function, and instead of making it return an element, we're going to make it return a sequence of 1 element, which element is the minimal. All right? So how do we do that? Well, we're going to take none if len is equal to 0, otherwise s01, we want the first element. So actually we're going to return s if len s is equal to 1. All right. Otherwise, it's going to be right. So remember that we don't have the type. It can be any type, right? So we always have to naturally create elements. So let's look at what mn returns, right? Mn is comparing 2 elements, right? But the interesting thing about a comparison is that we can compare sequences as well, right? So we know already that we can compare sequences because we can compare strings. But for instance, 1, 2 is smaller than 1, 3, right? So we are naturally extending comparison to sequences, again using the lexicographic order. So because of that, this min doesn't bother us, doesn't create a problem for us, right? So always, instead of min s0, we can always return s01 : 1, right? And here, so here we're returning a sequence, here we're returning a sequence, and assuming this returns a sequence, then this is fine, right? So by having done these changes, min_cq always returns a sequence, all right? And then because of that, we're going to have min_cqs plus sort, and this should naturally work now, I think. With the exception of this guy, right? So for this guy, we can extract and say here 0. Okay. So let's see if this works. T2 is not defined. Test 2. And now it works. Okay, so we played a few tricks, right? So we changed this function, and with this hash, I'm introducing a command. So we're going to say returns a sequence. One element. All right? So previously we would return a minimum, the actual element, right? We change that. So what we get back from this function is a sequence, right? It's either a string containing the smallest letter, or instead of a number, it's the tuple containing that number, right? Okay, so let's see how this works. So I'm going to say here -I, so we can play with it a little bit, and you understand what it returns. So if we have a sequence test 1 and 2, but both of them are the same sequence, right? So if I say min_cq of test 2, I'm going to get not 0, but the sequence containing 0, right? If I say something like 5, 4, 3, 6, 5, right? I'm going to get the sequence containing 3 and not 3 itself. Why is this useful? Because I don't want to care about what type of sequence this is, right? So I'm going to make it so that I use sequence operations, but not take into consideration what kind of sequence this is. We haven't discussed lists, but we sort of hinted at what lists are, right? And lists are completely different type, nevertheless. Lists and tuples don't mix. But the syntax is very similar, just that instead of round brackets, we use square bracket. So the interesting thing is that this function now works for lists as well. All right? And guess what? It works for sets as well. So sets are also completely different, but in syntax very similar. Sets are not subscriptable. All right, so it doesn't work for sets. It only works for lists and tuples, sequences. All right. So clear? Right? And to show you the fact that lists and tuples don't mix, right? We can try to combine them, they don't mix, right? Easy. Strings and tuples don't mix, right? Nevertheless, we have a function now that works for lists, works for tuples, and works for strings. Let's mix it up. Sorry, too many brackets, right? So it works for all these sequences, right? And how did we achieve that? We took advantage of all the common operations that are available for sequences, which is indexing, right? Comparison, which works in the same way, and appending, right? The plus sign. The plus sign is polymorphic. It can be used between any two strings or any two tuples or any two lists, but we cannot mix elements of different type. Okay, so let's take a look at this again, right? So we're using operations that are available on all lists, right? So here what we have, comparison. Comparison is available on sequences, right? Lexicographically. We have a sequence, right? We look at the first elements, compare them. If they're equal, we're going to look at the second elements in both sequences. If they're equal, we're going to look at the third, right? As soon as one is smaller than the other, we can decide which sequence is smaller than the other, right? And here, all sequences have a length, right? So the len is legal on all the sequences. All right, and then if the length is 1, we are returning a sequence of the same type as this one. I don't care what type of sequence it is, right? What I need to do is to return a sequence of the same type. So by putting S there, I'm naturally returning a sequence of the same type, right? And then, right, by performing this range selection, I'm returning a sequence of the same type. If it's a string, I'm going to get a string. If it's a tuple, I'm going to get a tuple. If it's a list, I'm going to get a list, right? And then by definition, whatever this returns too, right? But what this returns has to be compatible with what this returns, right? So they're going to be of the same type. So necessarily, I'm going to return a sequence of the same type as the one that was passed in as an argument. And this property carries over to sort, right? So when we're removing an element, we're returning a sequence of the same type. If it's a string, we get back a string, right? If it's a tuple, we get back a tuple. This operation performs the right thing, right? This expression performs the right operation irrespective of the type of the sequence that we have. Works for strings, works for tuples, works for lists. All right, and same here, right? So if the length of S is 0, I make sure that I return an element of the same type. Whatever sequence was passed in, the same type of sequence is passed out, right? Then we know that this carries over here, right? So whatever S, the type of S is, this expression, this expression has the same type. And now, by definition, because this is sort, right, whatever is passed in, right, so I'm passing in S, this carries over to here. Okay, so this is one tricky aspect, right? So this carries over to here, right? Now, notice that remove, while returning the same type as S, it doesn't take in the same type as S. It takes an element from inside S. So then in order to produce an element from inside S, we index with 0, right? Why? This highlighted expression is a sequence of exactly one element, right? So we can extract that element using index 0, right? This is exactly what remove expects. This is exactly what remove expects, right? Remove itself, this function, this expression, returns the same type as S, all right? And then, by definition, by the way we engineer things, sort will return the same type as its argument, right? Which can be combined with this to return the same type as the argument, right? So writing these kind of polymorphic, this is what we call polymorphism. It works for multiple types. Writing this kind of polymorphic functions or code is a very useful thing, right? Because obviously you write a single piece of code and then you can use it with different types of data. Sometimes you need tuples, sometimes you need lists, sometimes you need strings, and you don't have to write different code. It just works. Does this make sense? All right, so we have learned polymorphism just now, all right? And we have learned the fact that we can write code. What's the essential thing, right? Use only operations that are available on all the data types. All right, so finally we need to sort this one out. This one is a lot simpler, right? Because all we need to do is here we need to return S, right? And then here all we need to do is return S0, 1. Okay, and at this point we're done. So let's test this one. So this would be a function and we're going to say here, and I'm just going to use test2 here. And we're going to do the same tuple of reversed to and notice that it's true. We should have beautified this a little bit. And this is pretty much done. Okay. Now, I would like to learn. I would like to teach you how to do things with sequences, right? And we're going to use the tuples because these are the ones that we're using right now. So let's do next sequence processing. And we're going to learn what we call sequence comprehension, list comprehension, set comprehension, tuple comprehension, and so on. Okay. So we have the test2 sequence there. So let's say we want to compute the sequence of all the elements that are the square of the original elements in a given sequence, right? So we're going to say tuple of squares, and notice what I'm going to do, right? So I'm going to open brackets because this is a tuple, right? And I'm going to say x times x for x in test 2. Okay, let's make this actually a little bit clearer. I'm going to extract it from here, and I'm going to say squares. And I'm going to say squares here. Okay. So if we run this code, all right, the trouble is that we always get these generators, and I want to teach you about generators. Actually, I'm probably going to do it today. Let's see, tuple here. Okay, so we have a tuple of squares. Why do you see this? We're gonna get there very quickly, right? Python tries to be efficient. In being efficient, it will say I'm only going to compute this thing, right? This thing being this expression inside here, only when it's really needed. When it is really needed, when somebody wants to see it, for instance. When we print it, somebody wants to see it, right? Then we compute it, right? So at the point of creating this, all right, it is the promise of a computation. It's not computing right then and there, right? So we force the computation by putting it inside a constructor. All right, so by adding the tuple there, we essentially force the computation. I wonder whether I can actually do this. I guess I shouldn't be, but just want to make sure. No, so you see, actually we can do it. We don't need the double brackets. Cool. So so let's do more of the same. All right, so let's say I want to compute all the squares of even numbers in the sequence. All right, so squares of evens. I'm going to say x times x for x in test 2 if x percent 2 is 0. Okay, so now we can also do filtering. And one important thing would be to print, right? Because otherwise we can't see anything. So print of squares of all right, I would have hoped that Visual Studio would help me there, but it seems that it doesn't. So if we run this, you see the sum of squares of evens, right? what if we, for instance, want to generate all the pairs of numbers between 1 and 10? Right? We want to generate pairs. So we're going to say pairs equals tuple, and each element is a tuple, right? So this is going to be a tuple of tuples. So I'm going to say ij for I. I don't want to jump the gun, right? So because I don't want to jump the gun, I'm going to say range, RNG, is the tuple of numbers between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously, we should have a better way of, actually, let's not make the output too large, between 1 and 5, right? Obviously, there should be a nicer way of generating this range, right? And we're going to learn it soon. But for the time being, let's just do it this way because I don't want to jump the gun. For I in range, for j in range. All right, so this is going to be a tuple of tuples, and we're going to have tuple of pairs, and we're going to have pairs here. Okay. Is this clear? Does it make sense? Right? So there you go. The 25 pairs are there, right? If we want to generate triples, what would we do? Louder? Yes, very good. So we add a k here for I in range, for j in range, for k in range. Oh, sorry. Right, and tuple of triples. Okay, let's put this one a bit higher. So there should be 125 triples, okay? Works fine. What if we want the pairs? Let's stick with the pairs, right? So I'm going to delete this one because I don't want to see, or I'm going to comment it out, right? I don't want to see that output all the time because it's too large and it's going to become very annoying. Every time we run the program, there's a lot of output, right? So we're going to comment it out. But let's say now that out of the pairs, I want to select only those where the first element is larger than the second element, right? So I'm going to say ordered pairs equals, and I can take advantage of the fact that the pairs are there, right? And I can say, right, it's the set of pairs P for P in pairs, right? If P0 greater than P1. Right, so if you look at the ordered pairs, we have only pairs where the first element is larger than the second element. What if we want these? So, and they're also ordered in increasing order, right? What if we would want them in decreasing order? Change the sign. No. What I want is still the first element larger than the second element, but I want 5, 4 to appear first. And I wrote a word there that should already give you the solution. All right? Since we bragged so much that this reverse sequence works on any sequence, it shouldn't be a problem working on tuples of tuples, right? So I should be able to say here, reverse EQ pairs. And in doing that, sorry, I wanted not all the pairs, but ordered pairs here. So in doing that, notice that we are reusing code, right? So notice that we already had a function that was useful. We're taking advantage of that. I'm not writing a new code, a new piece of code to reorder, right? I'm remembering, oh, I already have this function that does the right thing. So let me reuse it. Let me take advantage of it. Cool? All fine so far? All right, so we have reverse. What if we wanted to write permutations of a sequence? So permutations of a sequence would give us a sequence of sequences, right? So if I take the sequence 1, 2, 3, what are the permutations of 1, 2, 3? Well, first of all, it's a sequence of sequences, right? The first element can be 1, 2, 3. It doesn't have to, but, right? 1, 3, 2, right? 2, 1, 3. 2, 3, 1, yeah, 3, 1, 2, 3, 2, 1. In general, if I have n elements, how many permutations are there? N factorial, very good. Okay? Very good. Okay, so this smells like what? Given everything we've done last time. So you see, we wrote a bunch of functions here, and each of them was recursive, right? So we're going to try to solve this problem with recursion. Def permutation, permute. We have a sequence S, right? So if S is empty, we return the permutation of an empty collection is empty collection, right? And we learned that the way we want to write the empty collection is by returning the same thing. Else. So now, let's say we have more than S is greater than longer than the empty sequence. What do we do? How do we get the rest of the permutations? So one strategy, which is always very good, is to assume that things work for a smaller sequence. What would be a smaller sequence? Okay, let's go back. So you see, this was we always needed a little bit of it's not always very straightforward, but you see here it worked for a smaller sequence, right? And then here, well, here it's not so clear, right? This is definitely smaller, but we couldn't have guessed it that easily. But on the other hand, if you look here, this is again a smaller sequence, right? So I'm assuming that it works on a smaller sequence. I'm going to have the recursive call on a smaller sequence, right? And the obvious thing to try, that won't always work, but the obvious thing to try is, well, this is a smaller sequence, right? S from 1 to the end is a smaller sequence, right? So let's say somewhere in here I have perm of S1 to the end. So this is a sequence of sequences, right? And obviously, because this is a sequence, the only thing I can do is it's the only thing I can do, right? So I'll have to put something in here. Does it make sense? The only thing, right? So P is each individual permutation that we get from this sequence of permutations. Yes? So let's go and think of this in the context of 1, 2, 3, right? This would be 2, 3 would be this smaller permutation, right? We're assuming that perm of 2, 3 works. We're assuming that perm of 2, 3 works. 2 and 3, right? So this would be equal to what? 2, 3 and 3, 2, right? So from this, how do we get the 6 permutations that we saw initially? Well, I'm going to take 2, 3. Oops. I'm going to take 2, 3, right? I'm going to take the first one. And I'm going to insert 1 at each possible place, right? So I'm going to take 2, 3, and I'm going to insert 1. So I can insert it before 2. I can insert it between 2 and 3. I can insert it after 3, right? Yes? And then I'm going to take 3 too, and I can insert 1 before 3, and I can insert it between 3 and 2. 1, 2, and I can insert it after and this is it, right? So it turns out that I have to have a nested for, so I'm going to have another tuple here. How do I perform the insertion? How do I perform the insertion at a position I? Well, I'm going to have P, 0, and I, right, plus S, 0 as a tuple plus P, I till the end, right? And actually here I don't need the 0. So this will be the insertion, right, for I. And unfortunately, I have to jump the gun now. And I'm going to say range of len S plus 1. Why didn't I want to jump the gun? Because you see, in the spirit of what we've discussed before, that Python doesn't want to be too eager. Range of 10 is a range. Tuple of range of 10 is the tuple from 0 to 10, right? So this is, as we saw before, this is a generator. It's an object that will be unfolded only when needed, right? Not at the point when we declare it, but at the point when it's actually needed, all right? So this is on-demand computation, right? And I wanted to avoid that till I would introduce what we call generators, but it seems that we can't do that, right? And it seems that we would be done, right? So actually we're almost done. We're not quite done. So let's see what we have obtained so far. Yes.
Do you have to name review or what do we mean?
Again?
The names don't match. The function name.
The names don't match. That's very true. Very good. Yes. All right. But it kind of looks like we're done. There's actually a major flaw in there. But let's see what the flaw is. I have to put return as well. Very good. That's not a major flaw, but okay. So let's come up with a test. So let's say print. Let's see them of and test3 equals And let's start with, and let's not make it so boring. Let's put, let's use strings. Okay, so permutations of test3, right, and permute test3, and let's see what we get. Obviously, because we are using so here we should say tuple. Okay. So we're getting nothing. Ooh. Range not len s, but oh yeah, len s. So the problem is when s is empty, we return empty, so there's nothing for p to iterate over. So, so there's two major flaws. Is S the correct thing here? So what are the permutations of the empty sequence? It's the sequence containing the empty sequence, right? Right? So unfortunately, there's no way to, so at this point we have to break our polymorphism. There's no easy way to generate an arbitrary sequence that contains the empty sequence. All right, so now we're going to see the major flaw. Shouldn't happen. tuple here as well. I code in a language called Haskell, which performs this conversion automatically, and I have a bias. All right. So notice now what happens. So now you're seeing the major flow. All right. So we would like to have a tuple of tuples, right? But it's actually a tuple of tuples of tuples of tuples. Why is that? Well, because right, so we're returning a tuple of tuples here, right? At this level, so let's say we have 3 elements, right? We're returning a tuple of tuples, right? And then at this level, we're returning a tuple of tuples, which means that at the next level, we're going to return a tuple of tuples, right? So instead of collecting these into a tuple, we should, right? We should take these. We should take these and add them together. Append them together, right? This, right? So how many tuples do we have here? So this is one level, this is the second level, and guess what? This is the third level. So we're introducing a new level of tupling with every operation, okay? So having these tuples together is not a good thing, okay? So let's learn a new primitive. Okay, so I'm going to go in here and I'm going to actually, the primitive is very simple, right? So function sum, I'm hoping this is not going to work. I'm just going to use a list. Right, returns the sum. The sum means that we're putting the plus sign between every 2 elements, right? So I'm going to put the plus sign between 1 and 2, the plus sign between 2 and 3, the plus sign between 3 and 4, and so on and so forth, right? So now, if I'm going to have a I can actually use a tuple here, no problem. It's going to have the same result, right? So now, what if I use a tuple of tuples? Right? What's going to happen? Well, this is the first element of the tuple, and this is the second element of the tuple, right? Right? So we're going to put a plus sign between those 2 tuples. So what are we going to get? Int and tuple y. Is it going deep? Okay, what if I have something like this? All right, so sum doesn't work. Sorry about that. So we're going to have to learn a new primitive, which is called reduce. All right, reduce, and reduce is still not defined here because it's Python 3. Ah, man. All right, let's Google. function. I don't like this. It's not prepared to learn this. But there used to be a reduce though, and not in func tools, but is there accumulate? Okay, built-in functions. Reduces here. Why does sum not work? Because sum starts with 0. Okay, so that's, but Python 3, I think, does not have. So if I go here and say 3.7, reduce is not here anymore. All right, I have to finish this somehow. So we're going to import func tools. We're going to learn more about this soon. And actually, I don't want to import func tools like that. I'm going to say import reduce from func tools. Import reduce. Oh, from func tools import reduce. Yes. All right. So what does reduce do? And let's say import operators. Operator. All right, operator. So reduce will place an operator between the elements of a sequence. All right, so we say reduce function, sequence, and possibly initial, right? So we're going to say reduce, and normally we would say operator dot plus or add, right? 1, 2, 3, 4, and we start at 0, right? And this will perform this operation 0 plus 1 plus 2, and the order of the brackets is very important, right? It's not different from what you know, as it is typical, but the associativity is very important. 3 and then plus 4, right? So it will perform this operation, whatever the sequence, whatever the initial value it is, right? So interestingly enough, right, if I'm going to, did I forget a bracket? All right. If I'm going to do it for strings, right? So let's say here I'm going to say ABC, A, B, C, and I'm going to start with the empty string. I should get the string ABC, right? So it's going to say empty string plus A, everything plus B, everything plus C, and we'll get a result, right? So the interesting thing is going to be now, what if I have a sequence of sequences? So I'm going to have a sequence of sequences. So we're getting where we wanted to get from the very beginning, right? And obviously what I want here is the empty sequence, right? So I'm going to get all the elements put together, all right? So this is exactly what we need for our code. Does that make sense? Instead of avoiding, so in order to avoid the tuple of tuple of tuple of tuple that we have seen, right? What we're going to do here is we're going to say from functools import reduce import operators operator, right? And I'm going to tell you next time why we use operator.add instead of just the sign plus. Okay, and now what we want to do here is to say reduce, and we say operator.add, and let's do it like this, right? We have our sequence and we have the empty sequence here, and we close our okay. So instead of having, right, so now, right, again, remember we have one tuple, two tuples, three tuples. But this reduce operation, right, if you look here, this reduce operations goes from tuple of tuples to a single tuple. So it reduces one level of tupling, right? So we have three levels of tuples, but reduces one level of tupling, right? So we're left with the two level of tuplings that we wanted to have originally. So let's try running this. I don't want strings, I want okay. And for some reason, so now we have the permutations, but for some reason we have too many of them, so they appear multiple times. Each of them appears twice. Why? Well, let's figure that out next time. All right, because it's already 8, and we're going to continue on this approach, right? We're going to talk about sequences. We're going to keep them immutable, and we're going to try to use recursion for quite a while. All right, because I think it's easier. Cool. Thanks for coming. See you next time.